example is similar to what we were just doing, but this time we need to draw our own triangle. So if I come over here and I draw a triangle, here's my right angle, and this is sine of theta. Sine of theta is 4/7. Okay, so I have to remember that sine is the so in SOHCAHTOA, so it's the opposite over the hypotenuse. So if this is my theta right here, and it could be either one, it doesn't matter, okay? This is just more accurate in terms of the length of the sides. Okay, this is my opposite over my hypotenuse, right? 4/7, opposite over hypotenuse. So this is again my opposite side, this is the hypotenuse, this is the adjacent side. So I need to use the Pythagorean theorem again to find this third side. So I've got, this is one of the legs, so I'm going to call that A. So A squared plus B squared equals my hypotenuse, or C squared. So A squared plus 16 equals 49. I subtract 16 from both sides and I get A squared is 33. So A is the square root of 33. Okay, so maybe you're thinking, we got to do another one of these, and yeah, but there's something I want to show you. So, okay, so we've got the cosine of theta. Remember, that's so it's adjacent over hypotenuse. So I've got the square root of 33/7. My tangent is TOA, so that's opposite over adjacent. And we have a little problem with this one, and that is that we can't have a radical in the denominator. So I need to multiply this by the square root of 33 over the square root of 33 to get rid of that radical in the denominator. Okay, so square root 33 over square root of 33 equals, and I think you've done this before, so hopefully you remember. This is 4 times the square root of 33 over 33. So that will be my tangent of theta. Now if it were me, I wouldn't care if you left it like this, but the rest of the world and your book, so when you're doing your homework, will want it like this. So, gotta comply, I guess. So, sine, okay, we've got cosecant of theta is the reciprocal of this, so we've got 7/4. Cosine and secant are reciprocals of each other, so we've got 7 over the square root of 33. And remember, we've got this in this radical in the denominator again, so let's get rid of that. So this gives me 7 times the square root of 33 over 33. And then finally, my cotangent of theta is the reciprocal of tangent. So I've got the square root of 33 over 4. All right, enough of those. So we have this special triangle. We've got a couple of them. And you're going to notice that we use the degrees 30, 60, 90, and 45 a lot. Those are very popular. It's more than popular. It's just what the angles that we use the most in trig. But there's something I want to show you. So we've got a 30-degree angle here. We've got our 60-degree angle here. Of course, here's our 90-degree angle. If this shorter side is 1, then the hypotenuse is 2. The hypotenuse in a 30, 60, 90 triangle, the hypotenuse is twice the length of this side right here. Okay, and then we've got the square root of 3 over here. And if you use the quadratic formula, not the quadratic formula, the Pythagorean theorem, you'll see that this all works out. Okay, but that means that if this side is x, this side would be twice that, and this side would be x times the square root of 3. So if this side is 4, if my hypotenuse is 4, Then this side is 2, right, because it's half. And then this side would be 2 times the square root of 3. And I am actually going to write this. I don't know if this is, I don't know if this is off. I bet you can't see that very well. Well, I'll write it again here in just a second. Okay, next one is our 45, 45, 90 triangle. And this one's nice because I've got 2 sides the same length, and that's because I have 2 angles that are the same. So if this is 1 and this is 1, then using the Pythagorean theorem, this is the square root of 2. So again, if this side was x and this side was x, then this is going to be x times the square root of 2. And these little shortcuts that I'm showing you are nice if you remember them. And if you don't, that's okay. There's other ways of finding sides of triangles without that. But anyway, it's just kind of nice to have that in your back pocket if you need it. All right. So these are some of the most used angles in trig. And if we draw our 30, 60, 90 triangle again, okay, and this side is 1, this side is 2, and this side is the square root of 3, then if I take the sine of 30 degrees, so there's my 30 degrees, and I take the sine, so that's opposite over hypotenuse, then the sine of 30 degrees is 1/2. Now the cosine is adjacent over hypotenuse, so that's the square root of 3 over 2. The tangent is opposite over adjacent, so that's 1 over the square root of 3. And we can't have the radical in the denominator, so again I'm going to multiply by the square root of 3 over the square root of 3. So I get the square root of 3 over 3. So that's tangent of 30 degrees. Okay, now if we switch it and we switch the angle to 60, now it's going to change a little bit. My opposite and adjacent sides flip-flop. My hypotenuse always stays the same. So 60 degree angle is my opposite over my hypotenuse, so the square root of 3 over 2. My cosine is adjacent over hypotenuse. And you'll see that the sine of 30 is the same as cosine of 60, because these are the same, and it's because they flip-flop. Okay, and then finally my tangent is my TOA, opposite over adjacent, and so that is the square root of 3. All right, so that's that triangle. The 45, 45, 90 triangle, okay, if I have 1 here and 1 here, and this is the square root of 2, and it doesn't matter which one of these is my theta, okay? So, because they're the same thing. So I've got the sine of 45 degrees. I shouldn't have put theta, I should have put 45 degrees. Okay, is opposite over hypotenuse, so 1 over the square root of 2. And again, I need to make that not a radical in the denominator. So I have the square root of 2 over 2. Okay, the cosine is going to be the same thing, my adjacent over my hypotenuse. So this is the square root of 2 over 2. And finally, my tangent is opposite over adjacent, so 1 over 1 is just 1. Okay, so I need to show you the rest of these. And these are going to help you with some of your homework. And this is also in your book, but this is 2. This is 2 times the square root of 3 over 3. This is the square root of 3. We've got the square root of 2, and the square root of 2, and 1. And these are all reciprocals, okay? Hopefully you've noticed that. 2 times the square root of 3 over 3. This is 2, and this is the square root of 3 over 3. All right, we'll go on in the next video.